All right, we are starting process capability example C. Boot weight. Must be concrete boots, 32 to 33 pounds, not ounces. And let's jump over into the problem. Oh, before we do that, don't forget, in the announcements, there are files of this information I'm giving you, 2 files, so that you can download and look at the formulas and work out the problems and anything else you want to do with them. And here is the worked out stuff. Remember, this is just my information, has nothing to do with you. It's just a random number generator. Our specifications are 32 to 33 pounds. This is our data. We're taking 3 measurements an hour. Here's our X bars. You know how to do that. And let's jump over to sigma. Remember, sigma is simply equals standard dev dot s, and we're just highlighting these. Do not highlight the times, do not highlight the headings, do not highlight the X bars. They will give you wrong numbers. So there's our standard deviation. Of course, the X bar is just that. Alright, let's go ahead and jump over to CP. Remember, CP is just the difference between 33 and 32, which is 1 pound, divided by 6 times our standard deviation, or sigma. And so it comes out to 3.87, which is a very respectable CP. Alright, remember, Cpk has to do with looking at these 2 values that we calculate and taking the smaller worst case scenario. And let's go ahead and do the first one. This one, we say we're going to do X bar 32.13 minus 32. Well, obviously that's a lot closer. 32.13 is a lot closer to 32 than it is to 33. So our problem will lie on the lower side. You can tell that right now. And it does. So again, it's X bar minus 32 divided by not 6 but 3 times sigma, or standard deviation. And that gives us a CPKL of 1.01. CPKU, we're going to take the 33 minus the 32.13 and divide that all by 3 times the standard deviation, and that's that number. Great number. Unfortunately, we have to take the worst case scenario, which is 1.01. So, moving right along. Is the process currently capable of producing parts to specification? Yes, indeed. The CPK is sufficient at 1.01. To meet specifications, the CPK needed to be at least 1.0. So just a hair better than the minimum allowable. A CPK of at least 1.33 would be better to provide a little more room for process variability. The lower CPK value is due to the parts being on the low side of the lower engineering specification limits. Because, like I said, remember, 32.13 is really close to 32 and further away from 33. So that's why that number is so poor. It's just kind of hunkered down in the lower end of the specification. Now, if the process was perfectly centered within the specifications, would it be capable of producing parts to specifications? Yes, indeed. The CP is the value of how our process would perform if it was perfectly centered in the middle of the specs. In an earlier example, I showed that when I actually put a number in to put it in the middle of the specification. In our case, the CP equals 3.77, which is much more than the needed minimum of 1.0. Definitely much more needed to produce all parts to spec. So yes, we are looking good. And it says, what happens if we were to double the specification? Instead of, let's say, 32 to 33 pounds, it was 32 to 34 pounds. Or 31.5 to 33.5 pounds. Then we would just simply double this, because the CP is just how what's the difference between the big number and small number. So if it's 1, now it's going to be 2, and so this ends up just being doubled, 7.74. And we go on to this one, which we've done before. It says, well, what happens if I'm trying to get a CPK of exactly 1? What would my specifications need to be? Now, we don't usually change specifications necessarily to do this, but sometimes the engineers allow us. So we end up using this formula. We say X bar bar, which is 32.13. It's going to be X bar bar minus 1, because that's our target. 1 times 3 times our standard deviation, and it gives us this number. And for the upper specification limit, if we wanted to change that, we would have X bar bar plus a CPK U, which we're choosing, we want to have a 1. So we put 1 in there, times 3 times our standard deviation, we come up with that number. And let's just suppose that we want to have a CPK of 1.33. Well, what would our specification need to be, our limits? And so we put in X bar bar, 32.13, minus 1.33, not 1, times 3 times the standard deviation. And similarly, X bar bar plus 1.33 times 3 times our standard deviation. And you can see that's what happened. Now, of course, as I mentioned earlier, I just tagged the 1.33 on the end because it doesn't really matter with mathematical hierarchy.